In the next two lessons, we're going to look at the general behaviour of waves. In this lesson, we're going to look at the property of reflection and refraction. And to do this, we're going to take water waves as an example. So the first thing we'll look at is reflection. And reflection occurs when a wave bounces off of an object. Okay, so we've got water waves coming in from the sea, and they're coming in and they're hitting a quayside like this. Okay, so this green line represents the direction of propagation of the waves. You've got the wave fronts coming in here like this, and the direction of propagation is in this direction. Now what we're going to do is we're going to mark a line called the normal, and this purple line represents the normal, and the normal is at 90 degrees to the reflecting surface. So what will happen to the water waves? Well, they're coming in this way, and after reflecting from the quayside, they'll look like this. Now, what can we say about the angle of incidence and the angle of reflection? Well, the angle of incidence is always equal to the angle between the direction of propagation of the wave, here coming into the quay, and the normal to the reflecting surface. So we can write I here, that's the angle of incidence, and the angle of reflection is equal to the direction of travel or propagation of the reflected wave with the normal to the surface, which is this angle here. Okay. So we can write R here for the angle of reflection. Now, how are these two rays related? Well, as in the case of all reflected rays from a surface, we can say that the angle of reflection is equal to the angle of incidence. That applies as much to water waves as it does to light waves or sound waves. And now we're going to have a look and see what happens when refraction occurs. Okay, so in this case we're going to look at refraction. Now, refraction occurs whenever a wave passes from one medium into another. Now, in the case of a water wave, we're talking about a water wave moving from deep water here into shallow water, that's the lighter colour blue, that's shallow water, and back into deep water again. Now, the change in depth of the water in this case represents a change in medium. So first of all, what you notice is as the water wave moves from the deep water into shallow water, it slows down. Okay, so it will move slower through the shallow water, and then as it passes back into the deep water, it moves faster again. Now, as a result of this slowing down, what happens is that its wavelength changes. So the wavelength of the wave is the distance between the two wave fronts, right? And as it passes into the shallow region, this distance decreases. Okay, the wavelength is less. And then as it moves back into the deeper region again, the wavelength increases. Now, when refraction occurs, the direction of propagation or direction of travel changes as the wave moves from one medium into another. But this isn't observed if the direction of travel of the wave is perpendicular to the boundary between the two mediums. Okay, so in this case, the boundary between the deep and shallow water is perpendicular to the direction at which the wave is travelling. So there's no change in direction of the wave. So let's have a look at see what happens when the travelling wave is incident on this boundary at an angle. Okay, now we've got the deep water here, and we've got the shallow water here, and you'll see that the boundary between the deep water and the shallow water is at an angle to the direction of propagation of the water wave. Now, as soon as the water wave hits this shallow region, it slows down, and a direct consequence of this slowing down is that it changes direction. So this now becomes the new direction of propagation of the wave as it passes through the shallow water. And it is this change of direction that we call refraction. Now, refraction, as with reflection, will occur with all types of waves. whether they be sound waves, light waves, or seismic waves. Whenever a wave is incident on a boundary between two mediums at an oblique angle, that's to say the angle is not perpendicular, then the wave will change direction.